really happy to be here. This is not the right slide, but we can do it. So I am really happy to be here today. As you say, I will be talking about how to scale machine learning in production. I think that talking about machine learning on a conference about enterprise is amazing. I can still remember when I was coming, this is the right slide, I was coming to a conference just to learn about how to train a model. Those days when the biggest of our concerns as a data scientist was around the model training. I'm not sure if everyone will share this feeling, but I'm pretty sure that for everyone here, training a model is not a challenge anymore. We are having different type of challenges today. I hope that today I have the clicker. Yes, that is the problem. Now I have. So today we hope that we'll bring some light on what are the challenges that we are having today. And for that, I will tell you the story about Riskified, how we went from a startup to a unicorn to a public company. I will tell you this story using the number of models that we have in production. I use this number because it's an interesting proxy to understand what is the complexity of our system. The story, don't worry, it's not that we have a exponential growth. Story is more interesting. The story of our models in production, more bumpy. We have some ups and downs. We will understand the story in four different sections. Each one will try to explain us the different challenges that we have over the time and how we achieve to create a machine learning system that was efficiency, flexible, and scalable. I hope that by the end of this talk, you will have some understanding of how we can scale our machine learning systems and what are really the challenges that we're trying to solve. I didn't present myself yet. I am Andres. As you say, I am a data science team lead. I am leading a multidisciplinary team of data scientists and developers. I study statistics and sociology, but most of my work was around machine learning infrastructure and how to scale our processes and create new capabilities. I was born in Uruguay. I have been living in Israel for the last 12 years, so I am kind of a mix of these two cultures. And as I tell you, I will talk about the story about Riskified. For that, I just will explain what is the problem that we are trying to solve here and how machine learning is part of the solution. So we were founded as a chargeback guarantee solution. And to understand what is a chargeback guarantee solution, you need to understand two main things. One is that every transaction that is made on an e-commerce, it has to be approved or declined by the e-commerce. That means that they have to decide on each transaction that they have. If they approve the order, and this is the second thing that you need to know, they are taking and they are assuming the liability of this transaction. That means that if the order results to be a chargeback, they will have to return the money back. Riskified came to here with the idea of shifting this liability from the e-commerce to Riskified. We will decide on each transaction using machine learning to decide if we will approve or decline the order. If we approve the order, we will assume the liability. This is interesting and it's really risky. Today, we are more than just a chargeback guarantee solution. We have different products. We define ourselves as a solution, as an enterprise solution solving the biggest e-commerce risk management problems. We have more than 700 employees, and we review in 2020 more than $60 billion. And remember, we are taking the liability of each approve, and every decision is made by our models. This is Riskified from today. The very early ages and how we started to create this machine learning process was a little bit different. And as every startup, our first problem was around minimal data and cold starts. But don't worry, I will not talk about this. I will talk about scaling. Because our problem shifts really fast from minimal data to scale. In the first year, we will have around 100,000 orders. But 2 years after, we were having more than 80 million orders. And if you understand the problem of this scale and the challenge that we are having, you will understand that really fast we were having to scale the process. The first thing that we do to scale this process was around the platform, the model training. This is the core of every scaling process. This is the core of every machine learning system. At that time, it's like some years ago, we look at the process as just three components: the dataset creation, the model training, and the model validation. And we focus on this. And we really scale our process. We really achieve to go from a few models to many models and to support the hyper growth of the company. But we will learn something important here, because training many models and deploying many models is not the same as managing many models. And this is a lesson that we will have to learn. So the next part is paying down the technical debt. And I think that many of you will already know what is the message here. This is a big paper, everyone I assume that know, but I think that I cannot bring a talk about machine learning infrastructure without mentioning. Understanding the difference between training a model and really having a machine learning system in production is a big difference. And you need to understand the complexity. I'm not sure how this will be manifest for every person here, but I am sure that if you don't have the right infrastructure, having many models in production will be a headache. We'll have a high operational cost and will be many different challenges. So we took the idea of the paper, we have our machine learning code, we have all the surrounding, and we have a clear goal during these years. Our goal was to mitigate the complexity of having many models in production. This is the idea. And for that, we took and we work on many of the different components that we have. We decided our goal was to make the process simpler. So one of the first things that we did was around make the models talk in the same language. The idea is to make the process of replacing models easy. The other part was around the monitoring. Understanding that something is not working properly is key in this area. Understanding that you are having a problem is really, really important. But just knowing that you have a problem sometimes is not enough. And this is an important part. This is an important tool that we started to create. By the beginning, we were working and trying to understand every model. What is the performance of every model? For that, we started to create new tools to don't look and don't check every model, starting to look at the whole picture. The idea was creating an anomaly detection tool that was really scanning and monitoring every segment in our population. These are billions of different segments. And trying to understand if there is an anomaly in the number of orders that we are seeing or in the risk that we are seeing in this population. Another part was around the network analysis tool. Creating and understanding the connection between the orders was key and really important for us. The idea here, and what is the important part of these two tools, is that we were starting to create some components that will help us not just to say that we have a problem, because saying that you have a problem is easy. You can see it in some metrics. But understanding where is the problem, that was one of the keys. So during this year, we really started to focus more on the surrounding of the algorithm, less on the algorithm himself. But by simplifying all these other components and making the process a more clear monitoring of all our machine learning system, we started to achieve more and to extract the full value of our models. And this is the reason that you see the drop in the number of models. We didn't need so many models to really manage all our population. Now we can manage all the process with significantly less number of models. And this was important. The next era is accelerating the research cycles. We are not, in this moment in history, we are not a startup anymore. We are becoming a unicorn. Our business really expand. Not just our business, also our team. We went from few data scientists to more than 30 data scientists. And now we have a clear vision. We want to create the best fraud prevention solution in the world. And for that, we need to have the most accurate models in the world. And if we want to have the most accurate models in the world, we define a clear goal. We want to shorten our research cycles. The idea is that having shorter research cycles will allow us to test more things. Testing more things will move to more innovation, and more innovation will be translated to more accurate models by the end of the day. And this is our goal. For that, we took our component, and our big structure of the model training, we rewrite it, and we take it and created a more clear interface between the different components. The idea was to make the process to go smooth and to make every data scientist able to use this process. At the beginning, the full cycle of the training was between several hours to many days in some occasions. Now we wanted to shorten for a few hours in the worst case scenario. The thing that we focused was around the model pipeline and creating and moving all the things to work with Spark. This really helped us. The other part was also around the hyperparameter search. If we want to have the most accurate models, we need to be sure that we are testing and making the best hyperparameter search. But many times this was a bottleneck, because if you are testing and you are trying to do, this is a problem. So we took and we implemented a parallel of Bayesian optimization of this. This really allows us to add more computational power to make the models to converge faster. The other part was around to creating a model agnostic model training library. And this is really, really important, because by doing this and making this process a model agnostic, we are allowing every data scientist to implement some few different classes and be able to enjoy the full power of our platform. And if we want to make innovation, we need to allow our data scientists to test different things. This was a big success. The number of models that we had during this year, that we trained during this year, was amazing. We skyrocketed the number of training models. The number of models that we were training a year ago in a month, now we were training a day. But the problem was that we were seeing a lot of value, but not real value. We were seeing a lot of potential value. And this is the last part of the story. And I think that this is the part of the story that many of the people here are. It's the MLOps revolution. The idea is going from a research to production. This is the challenge today. And this is, I think, that we are trying to solve. Because we understand that the real potential of all the technology that we are creating is on the deployment. It's when we are seeing this really deployed. We were focusing before reducing the research cycles. Now we are focusing on reducing the end-to-end process. The idea is to go from an idea to a production as fast as possible. If you remember some slides ago, this is how we look and how we define our system. Many different boxes. Today we are trying to look at the process as a more holistic way, as a fully integrated system that is connected one to the other to really make all the process and making all the new additions that we are creating fast and good to be deployed. We are having 10 new features. I will put it in my feature store, and my next auto train of the models will take these things and go until the end and deploy. I have a new algorithm, it's the same. A new way of servicing is all the same. It's one big thing. It's not many different boxes. There are many challenges to create something like this. And I think that continuous training is one of the first things that we need to understand. And I think that one of the changes on the way that we are looking at the process is in the conception of what is our goal when we are doing a research. Some years ago, the output of our research was a model. We understand that this is not our goal anymore. We don't want just a model. Our goal is to create a signature of the model. It's some kind of YAML, some kind of configuration recipe that will tell me how to train the model again and again and again. I don't want to every time to invent the wheel. And this is the idea, to have a fully integrated system that will explain how to create this process. But to achieve having a fully integrated system and to have a continuous training, as some people talked here before, you have to build many different components. You have to create a good model validation process. You have to model validate each one of these other things, talking about concept drift, population drift. All these things you need to be sure that you are taking care of. And this will move me to the last part of the things that we'll learn during this year. Creating a machine learning system today is complex and have many, many moving parts. I think that it's not trivial that we are seeing so many startups today trying to solve this problem. It's complex, and at least 2 years ago, in Riskified, we have built every component, we build it in-house. In a way, because many of the things that we needed, there wasn't out there. We had it to build. There wasn't many startups. But in the last years, there are many things and many startups working. We started to work with Superwise some years ago because we understand that we are having many challenges, and we need to focus on our challenges, not creating all these processes. So I think that one of the things on the trade-off of build or buy is one of the things we changed when we started to create and try to approach the MLOps revolution. So this is the last part of the story. This is the current state. We are really now scaling our processes. We are now seeing more models in production. It's not that because we want more models, but this is the output of having a shorter research cycles and an easy way of deploying the process. So this is the story of Riskified. This is the 4 different sections that I wanted to tell. This is the parts how we create and build an infrastructure that was flexible from one side, was reliable, and was scalable. If you're a startup, clearly you don't have to pass all the things. Many of the things that we have to pass, we didn't have the technology. But there are some lessons that we learn of the process. First is you don't have to run to scaling. Or if you have to run to scale it, remember, sooner or later, you will have to pay the technical debt. There is no way to escape. You need good infrastructure to really be able to scale your process. The other part is accept that your models are not perfect and invest time and effort and resource to really make able to understand what is going wrong. This will save you a lot of money. Don't measure your time around the research. No one cares. The real question is how fast you can go from an idea to production. This is the real challenge. This is the real focus. If you want to scale your machine learning system, you need to focus on these things. And the last thing, as I said at the beginning, it wasn't so long ago when the biggest of our problems or our challenges was around the model training. 3-4 years ago, talking about training a model is funny. It's not a challenge for anyone here. We are having new challenges. And I think that 6 years from now, when we were sitting here talking about MLOps, we will also, okay, yeah, we can just do it with 3 different clicks. So I think that you need to understand what are your focus and what are your critical issues that you need to solve, and focus on them. Look outside for quick wins. This is the best way that I think that you can really scale your process. This is all what I have. I know that it's before lunch, so thank you that you are staying with me. And if someone has any question, I will more